All right, for example 1, we're going to be using the angle relationship that we learned earlier in our notes today. And we're going to be solving for x using those angle relationships. So looking at example 1a, we see that the vertex lies on the circle, meaning this creates an inscribed angle. So we'll make note of that so we know what relationship we're going to be using. We're given that the angle measure is 35 degrees, and we're trying to solve for the measure of the intercepted arc x. So we know that 35 degrees is going to be double the amount, or half the amount of x. So we're going to take this unknown x and divide it by 2. When we do our algebra, we get that x equals 70 degrees. So that would be the measure of the intercepted arc. Looking at example B with circle K, again we see that the vertex lies on the circle, so we have an inscribed angle. The difference here, though, is we're trying to figure out the angle measure, but what is the measure of the intercepted arc? Well, since this is creating a semicircle, I know that my highlighted area, my intercepted arc, is going to be 180 degrees. Now, using my angle relationship, I know that x divided by 2, or x will equal my intercepted arc of 180 degrees divided by 2, meaning that the measure of x is 90 degrees. Okay. Now looking at C, this one looks a little bit different. We can see that instead of intersecting on the circle, it intersects inside the circle. So that means we have an interior angle relationship. So since they intersected inside the circle, then the measure of each angle is half the sum of the difference of the intercepted arcs. So I know that I have 120 degrees is going to be equal to the sum of my two intercepted arcs added up and divided by 2. So I have now we're going to do our algebra to get us further along. And we can see that x is equal to 160 degrees. Looking at example D now, we see that this one's different as well because our angle lies outside the circle, meaning it's an exterior angle relationship. For our exterior angle relationship, we're trying to find one of our intercepted arcs, and we're given our angle measure and the other intercepted arc. So we know that the point outside the circle is going to be half the difference of the two measures of the intercepted arc. So we can say that we have our given angle of 20 degrees is equal to the difference between our intercepted arcs divided by 2. Now I'm going to do our algebra. And we get that x equals 90 degrees. Okay, again, looking at E, we see that our point lies outside the circle, making it an exterior angle relationship. We have one of the intercepted arcs of 70 degrees, and we need to figure out what my other intercepted arc would be. So we know that a full circle is 360 degrees, but we have to subtract this given section and even our 70. So when we calculate that, we can see that we have another intercepted arc of 130 degrees. So we'll plop that in. So again, our angle, our exterior angle x, is equal to 130 minus 70 over 2. So our intercepting arcs divided by 2. When we do our algebra, we get that x is equal to 30 degrees. Now lastly, looking at F, we are given a point outside the circle, meaning that it's an exterior angle. We know that the measure of the exterior angle is equal to half the difference of the two intercepted arcs. So we have this arc here that we don't yet know the measurement for. We are also given an intercepted arc of x. Since we don't yet know this bigger intercepted arc, well, we know a whole circle is 360 degrees and that the other remaining part is x. So we can call this arc over here 360 minus x. Then, using my exterior angle relationship, I can say 360 minus x minus x. So now we can simplify. We have 80 is equal to, if we combine like terms, and x is equal to 140 degrees. Hopefully this helps. If you still have more questions, feel free to email your teacher in regards to that. Have a great